Hello, this is Captain Chaudhari. Today I want to speak about some very simple, basic, interesting facts about the tides of moon. Tides caused because of moon and sun. As you know, the tides on the earth basically are caused by moon and sun. Now, if we consider the distances, if we consider the sizes, the size of sun is tremendous. It is much bigger than the size of earth and moon put together. But the distance is quite a bit. Compared to moon, the sun is very far away. This is the reason that sun's gravitational pull is just about 0.46 of the moon's gravitational pull, which means that the moon's gravitational pull is more than twice that of the sun's gravitational. You must have seen in the pictures, like say this is the earth and this is the moon. You must have seen there is a heap at the sublunar point, and there is also heap on the other side. I can understand there is a heap under the moon because of the gravitational pull, but why there is heap on the other side? Yes, this never came to your mind, this person who has drawn this diagram, why he's drawn heap here as well as here. Let's try and understand why there is heap on both the sides. Let's consider 1 gram of the solid earth and adjacent 1 gram of liquid water. Let us see what is the gravitational pull on, what is the force of attraction between the moon and that 1 gram of water or 1 gram of solid earth. Now, when we consider this distance, that is the distance to 1 gram of water, the gravitational pull is equal to g m, that is the mass of moon, into 1 divided by r square, where this distance is r. Right? But when we want to find out what is the gravitational pull for this 1 gram of solid earth, 1 gram of solid earth cannot detach itself from the rest of the earth. So the position of this 1 gram of solid earth would be considered at the center of the earth, where the distance becomes r plus radius of the earth, right? So the pull is going to be g m into 1 divided by r plus r whole square. So you can see the gravitational pull on 1 gram of water is much more compared to the gravitational pull on 1 gram of solid earth. That is the reason we have the water being pulled towards the moon. It appears in the diagram that the mass or the body of water is pulled towards the moon. Now, if we consider 1 gram of water here and 1 gram of solid earth, the position of 1 gram of solid earth should be considered over here. The gravitational pull on 1 gram of water is equal to g m into 1 divided by r plus 2r whole square, whereas 1 gram of solid earth would be considered at the center of the earth, in which case the gravitational pull for that 1 gram of solid earth, 1 gram of earth particle is going to be gm into 1 divided by r plus r whole square. So once again we see that the pull on the 1 gram of solid earth is much more compared to the pull on 1 gram of liquid, which means that there is a greater force acting at this point or on the earth in general compared to the rest of the water. So how this has to be proved visually in terms of equilibrium? So we say that the earth is getting pulled towards the moon and the body of water is left behind in the space, and that appears as a heap on a point which is not sublunar but on the opposite side of the sublunar point, right? So that's why we have heap on one side and heap on the other side. Similar thing is done by sun also. Sun also causes a heap, right, at subsolar point and at the point which is 180 degrees away from the subsolar point. Having understood that the heaps are caused by the sun and moon, let us try and understand what is spring tide and what is neap tide, right? So basically if we say that this is ecliptic, right? if you say this is ecliptic and this is the Earth, Earth and Sun have to be on the ecliptic. You cannot imagine ecliptic without having the center of the Earth and center of Sun on the ecliptic. Let us say this is the ecliptic, and if the equinoctial, which I have to show 23.5 degrees inclined to the ecliptic, this becomes the axis of rotation, right? And you are likely to find sun, moon, sun always on ecliptic and moon quite close to the ecliptic. Say, suppose the moon is over here, right? And incidentally, if the sun is also in the same line, that means the sun, moon and earth are in one line. It does not make any difference whether the moon is on this side or moon is on the other side. When the moon is over here, it is called conjunction. Moon is in conjunction, and if the moon was here, it would be opposition. In either case, there would be a heap that is caused because of moon, and there would be heap that is caused because of sun. So the tidal forces of moon and sun, they combine. You know, there is high water caused by moon and sun over here as well as here, and low water is caused at the points 90 degrees away from the high water points. Now this phenomenon is called spring tide. Now spring tide would happen, or spring tides are associated with full moon and new moon. Now let us talk about the neap tides. Here's the earth. You have, say, sun over here. The sizes are not in proportion. And suppose the moon is over here. Now this posture is called quadrature. Quadrature means the elongation of the moon is 90 degrees east or west. So if the moon is over here, moon is going to cause high water at sublunar point and on the opposite point, whereas the sun is going to cause high water under subsolar point and a point diametrically opposite. Now what is happening is, moon is trying to cause high water here and here, low water here and here. Sun is trying to cause high water here and here, and low water here and here. So here you can see that the tidal forces, they don't combine. In fact, the tidal forces of sun and moon are acting opposite to each other. And when this happens, the high water that you will get is less than the normal high water, right? One of the lowest high waters, and the low water that you are going to get is one of the shallowest low water. That means it is not going to be a low water which is very deep, right? So high water not so high and low water not so low. So this is what is the neap tides. Now let us try and see what is the priming and lagging of the tides. In this picture, if I show you the earth over here, right, and moon I would show in the first quarter. So what happens is, the gravitational pull because of moon will act in this direction. I will show by this vector, and gravitational pull of sun is in this direction. The gravitational pulls, if I show the forces with the help of a parallelogram, I would say the resultant of the two gravitational pull will cause a high water in this direction and in the opposite direction. Yes? When this happens, as you know, the earth spins anti-clockwise, as you see from top. If there is an observer over here who goes along the earth because of the spinning of the earth, he will first find the sun crossing the meridian, and then he will find the high water heap, right? He will meet the high water heap, and thereafter the moon will cross his meridian. So when the man comes here, he is under the sun. When man comes in this position, he observes the high water, and when the man comes in this position, he finds the moon crossing the meridian. That means the high water he finds is happening before the meridian passage of the moon. So this high water which is happening before the meridian passage of the moon is actually, this effect is caused because of the sun. We call this priming. Priming means you get high water. Normally, the high water is associated with the meridian passage of the moon. So you find high water happening before the meridian passage of the moon. This is called priming, and this will happen when the moon is in first quarter and moon is in third quarter. Now let us try and understand what is lagging. So when the moon is in second quarter, what happens is the gravitational pull of moon wants to have high water in this direction, gravitational and this direction, and gravitational pull of the sun causes the high water in this direction and this direction. Now this force is bigger than the force that is caused by sun, but if you consider the parallelogram, you find that the resultant direction of high water would be in diagonal direction. So when you have a heap over here and you have a heap over here, and a person that is traveling with the earth because of spin, he will first find the moon coming on meridian, and thereafter he will find the high water heap. He will pass the heap after having the meridian passage. This is called the tide. High water is lagging. That means the high water is lagging behind the meridian passage of moon.